progress.
For those who have not attended in the past, Deerville Labs Speaker Series is a monthly event where founders and leaders share advice on how they overcame challenges, capitalized on their target market, and develop their product, providing you with actionable insight for your own products and processes. For more information, you can find us on Facebook, online at centralmaine.org and deervillelabs.org under our Speaker Series tab. I'd like to thank our sponsors for this evening's conversation. This free event is presented by Deerville Labs and is sponsored by CGI, Valley Beverage, Thomas College's Harold Alphon Institute for Business Innovation, and Bricks Co-working and Innovation Space. In addition, this conversation is being recorded and will be available for later viewing on our YouTube channel. This evening's conversation is presented by Timber HP by Go Lab Incorporated with founder Dr. Joshua Henry. In this speaker series, Joshua will discuss how Timber HP by Go Lab is using sustainably harvested softwood chips to make construction insulation for the North American market that's renewable, recyclable, safe, easy to install, carbon storing, and healthy for the home and the planet. With that, I will pass it off to Dr. Joshua Henry. Great for joining us.
Thank you for inviting me. And I have a lot of material throw at you. I might not get through all of it, but you can feel free to stop me at any point if you have questions. I'm going to start just by playing a video that our marketing team put together that sort of gives you a background for how we got started. And then I'll move into a presentation.
You know the way I want it. If you lived on an island, probably would be fishing. If you lived in the desert, you'd be doing something with sand. But we live in a sea of trees. It's only natural to make a living from the woods and off the land. We make square boards, rectangular boards out of round walls. We make a lot of chips. Those all go to paper companies. The paper industry has been suffering. When we lose our paper company, we lose the market for those chips. And that means that the whole wood industry remains suffering. We need markets for low-grade wood.
Buildings account for about 40% of the total carbon emissions globally. Buildings have to save energy to address climate. One of the advantages of having a design build company, not just being an architect, is that you get feedback every day about the building you're building, material you're using, how it's going. It really depends on the insulation product you use as to how effective you're going to be in actually saving carbon. We've always had complaints about insulation. It's itchy, it's scratchy. We make all these microplastic people that they have kind of scratchy respiratory issues after using things and full respirators and buy that suits in many cases to install that. We knew there's a problem. It takes about 8 years of energy savings, carbon savings, and emissions to pay for the carbon of the original installation we installed when we using conventional insulation. Quite frankly, we don't have 8 years to wait. You just pick it up, you know what it is, you know that it's wood fiber. I wanted to know more about the product and how it performs, and then it said, best in class acoustics, best in class vapor permeability. So we knew about wood fiber insulation from Europe. We're talking about a material that's natural, it's 95% wood, there's no added toxins. And I said, when are we going to use it? And he said, never, because it's manufactured here and shipping it is not, a business model that works. And I just couldn't really accept that. I couldn't understand why this product is not manufactured in North America, where we have better wood resources than they do in Europe, and we have a building style that fits this type of insulation better than what they have there.
Maine all my life, and we drive around Maine. Any town you go to, almost, there's some buildings sitting there that's something you should do. Most people don't realize what a tremendous economic engine the paper mill is. They employ hundreds of people.
The people who worked at the UPM paper plant for so many years, their intellect,
their capability, their passion for forest products for the community. Losing that out of your community, a small community, is absolutely devastating. When we're up at full production, we're employing more than 100 people in that community. Well, those are 100 good paying jobs in a community that is a couple thousand people. That has a multiplier effect that is massive for the overall community. And it really is the identity of a lot of these communities. And they need working forests in order to grow the forests, in order to keep them viable. When it comes to Madison, it's right in the heart of the wood basket for Maine. We have a huge market in the Northeast for insulation. It's the biggest insulation market in the entire United States. We have a lot of existing housing that needs to be upgraded.
The key to addressing the climate crisis with buildings is to not only save energy in the future, but also do it with insulation products that come to the job site with a negative carbon footprint or that are carbon storing. And wood fiber insulation is the only scalable option that can do that. You know, it's easy to handle, it's very familiar, it's not scratchy, they can cut it easily. The byproduct of the cutting is sawdust. With wood fiber, you never have that impermeable layer, and like Gore-Tex, it allows that moisture to move through the assembly, not causing any mildew or rot in that wall assembly. And so the game-changing aspect of wood fiber insulation is that not only does it have favorable building performance attributes, but it's also cost competitive. And that's really key to the success of any insulation, is that it has to be cost competitive with the alternates in the market, but also bring the building science performances that we need.
There's a dynamic industry, and we have to keep changing to keep up with the times. Every time you add a little more value, and you lose some of the competition time. Well, I see the same thing with Golec. They're gonna make at least 3 different products there, you know, that's adding value. Wherever there's timber, there's sawmills, wherever there's sawmills, there are residuals that they need to get rid of. And everybody I know that burns their chips would rather sell their chips to somebody like a Golec or a paper company. Once the reputation gets out there and what a great product this is, and people learn how to use it, I think it will go.
Thank you for humoring me on that. Really, I just like to, it pumps me up to hear Jim Robbins speak. So he's just an amazing resource that we have in the forest products industry. My talk, this slide deck is mostly about our product, but since this is a group about entrepreneurship and small business, I thought I would start by telling you a little bit about how we got to this point. My name is Joshua Henry. I'm the co-founder and CEO of Timber HP. We started this in 2015, actually. Both the co-founder and myself are from Belfast, Maine. In 2019, we bought this facility, which became our headquarters in Madison, Maine. This is the former UPN paper mill in Madison. We bought that for $1.9 million in 2019 and set about engineering, re-envisioning this former paper mill as a center for manufacturing wood fiber insulation. In 2021, we closed our financing for the overall facility. Overall fundraise for the facility was about $150 million. 85 million of that was, a key piece of that was a tax exempt bond that we closed with Citigroup. And that was sold on December 23rd of 2021, just in time. And that allowed us to finalize all of our contracts. Our contractor on the site and the build out is Chimbro, which is a well-known company to many here. But what I thought I'd tell you about before we get into the product itself, is why we would do such a foolish thing. I'm not a manufacturer. I have no background in forest products. I'm actually a PhD chemist. When this started in 2015, I was a professor at the University of Maine in the chemistry department. My co-founder that you saw in that video, Matt Amalia, is an architect. In 2008, at that great time for the housing market, he's an architect and entrepreneur and started a business called Geologic, which was a design build company. And they built the first certified passive house in Maine, which was the 12th in the country. And for those of you who don't know what passive house is a science and engineering based approach to design and construction that results in buildings that consume 1/10 of the energy of those built to standard code. So that means you're paying 1/10 for heating fuel. And I just thought that was amazing, that could actually be done. But what I really liked about Matt's pitch about what he was doing was that the way he presented it and the logic for passive house was not about being the greenest product on the market in terms of building a house. It was really in terms of the idea that the reason you're reducing that energy consumption by 90% is to focus on the building envelope instead of the heating, ventilation, and air conditioning systems. So those expensive boiler systems and air conditioning systems, if you reduce the energy load by 90%, you completely re-envision the way that you're building the building, the way you're designing the building, and you eliminate those expensive HVAC systems and potentially come in first cost competitive with standard code construction. And when I heard that pitch, I didn't really believe it, to be honest. But I thought if you could do that, well, that's not the most environmental approach. That's just the future of building. If you can provide something to someone that is first cost competitive and you're saving 90% on energy, it's an obvious win for the state of Maine, but it's an obvious win for pretty much everyone. No one wants to consume energy. Energy is just money. So I really like what he was doing, but my background in chemistry is, my wife always says, yeah, he's a doctor, but he's not the useful kind of doctor. I taught quantum mechanics and thermodynamics. My research and development background was in materials chemistry, which is the chemistry of solids. I focused on next generation materials for renewable energy generation and energy conservation, so somewhat related. The reason Matt's pitch appealed to me is because I had spent 10 to 15 years working on next generation materials for photovoltaics or solar cells. And one thing I always point out to people is the reason that you see solar development all over the place, even in the state of Maine now, is not because people suddenly got religion about renewable energy. It's that about 10 or 15 years ago, scientists, engineers like myself started to focus on producing materials that were not the most efficient devices, so not taking the most amount of sunlight and turning it into electricity, but focusing on materials that were on an amortized basis, cost competitive with coal, natural gas, nuclear energy. If you can do that, it really doesn't matter how efficient your device is, you're going to be competitive in the marketplace. And that sort of resonated with me because, when I saw that and I saw it being effective in terms of solar being able to be incorporated into the market on a larger scale, it sort of set off a bell in my head that if an environmental technology is going to be successful, not just in a niche market, but in the overall market, it has to be cost competitive with all of the other technologies that are out there. And so when Matt told me his story, I thought it was great. I thought, I am an academic. There's nothing more useless or worse than an academic. I'm sorry for any academics out there, but I have a long history with it. And I just thought, I can't help you. You're building houses, you're an architect. But Matt was more convinced. He was like, no, we have real material challenges. And I started to study what they were doing. And I went to a job site. We were building a school in Belfast. And before the Robbins lumber sheathing is on the exterior of the building, you get there, and what I saw was basically a giant cheap beer cooler. So how do you insulate a house so that you reduce energy consumption by 90%? Well, 90 to 95% of the market in the insulation market is foam, fiberglass, and mineral wool. So in order to do that, you're basically attaching 8-inch blocks of big styrofoam. And I just thought, as soon as I got there, I was just like, so you're telling me that the most environmental approach to building is doing something that when I was a kid, we were trying to eliminate styrofoam coffee cups and things like that. That this material is the way that we're going to save the environment. I just thought, you're just replacing one environmental disaster with another. And Matt was sort of like, he really did not like the giant cheap beer cooler comment. But I could see that it was resonating with him. And then one day we walked into the conference room and one of these pieces of wood fiber insulation that was manufactured in Europe was on the table, and I asked him about it. And he said, yeah, it's a great product. It's performance competitive with all of the installations we have here in the United States. And it's actually better because it's vapor permeable like Gore-Tex. So it doesn't just insulate, but it allows moisture to breathe. And a house looks like a person. When you're wearing a jacket, the analogy we always have is a rubber raincoat. That old rubber raincoat. Some people are nodding, but you don't look old enough to remember these. But a rubber raincoat, so you go outside, and it's raining outside, and you start running around, and in a few minutes you're still wet on the inside from sweat. It's like pointless. And then Gore-Tex was introduced, and now it's all about breathable fabrics. Well, foam is just plastic, and the insulations we have don't breathe. Wood actually breathes, and our insulation is much like putting a Gore-Tex shell around the building instead of a plastic rubber raincoat. And so, I was like, that's amazing. He was like, yeah, it's great. And I said, when are we going to use it? And he said, this insulation is only manufactured in Germany, and shipping insulation on a good day is air. It's basically as light as you can get it. And shipping air from Germany doesn't make any sense. Like, it doesn't take a business genius to figure that out. And like it said in the video, I just said, okay, so we manufacture wood products all day long. Why is that not manufactured in North America? I took it to some of my colleagues at the University of Maine. They were like, I've never seen it before. And we started to write some grants to the state and federal government that were funded. And we did some testing on the products first to just figure out could the feedstock that we have in Maine be used to make this product. That was pretty easy. But what was really interesting is Matt and I both had the benefit of having worked in Germany for a number of years. We both spoke fluent German, and Matt was like, let's just go there, see what they do. And we basically just knocked on some doors in Germany at some facilities, and they were like, yeah, we don't know why this isn't manufactured in North America. It's been around for 20 years in Europe. It's $1 billion product here. We're interested too. And they gave us basically a look under the hood of what it was like to manufacture that in Europe. Gave us all of their financials. And we just plugged that in took the numbers we had from our investors who were in the forest products industry in Maine, and plugged that in, and we saw two things immediately. One is wood costs are about a third, residual costs here are about a third what they are in Europe, and energy costs are half. And if you look at that product, it doesn't take a PhD in material chemist to understand that product is just wood and energy. You're just taking the wood and applying energy to break it down into a fiber. And if you reduce those costs by a third, down to a third and a half, you take a product that in Europe was 15% higher in cost than mineral wool, fiberglass foam, and you make it a cost competitive product with all the products here in the United States. And you do that, and you get a product you get the best, you get a cost competitive product, you get the highest performing product, you get a product that's renewable, recyclable, non-toxic, and you get a product that you feel good about when you put it into your homes. Everyone, who has done a little bit of home renovation, has put their hands on some fiberglass. And, everyone has cut a piece of foam board for some reason or another and seen all those pieces go off to nowhere and you can't pick them up and they're sticking to your. Our product, when you cut it, sawdust. And what's amazing about the product is that it's the only product on the market that's carbon storing. It's also the only product that has a single feedstock that can address all three of the major insulation construction markets. Timber fill, our loose fill product that can be used as a dense pack insulation in wall cavities or an attic insulation, so the insulation that's blown into your attic cavities. Timber bat, which is a press fit into a stud cavity. You saw some of that being demonstrated in the video. And the product that really got this all started, which is the timber board, which is a direct above grade replacement for foam board insulation. That's really important because new code for driving higher efficiency in the building market, which is becoming mandatory, will require exterior above grade insulation, and the only viable product out on the market right now is foam. That also happens to be the product with the highest carbon footprint and has, basically if you install that foam, yes, you save on energy, but the payback for manufacturing that foam is 10 to 15 years. So a little bit more about the product and what the history of the product is in Europe. There are a number of this has evolved over 20-25 years. There are 3 products. They all sort of came over that 20 to 25 years. There are, you can take my word for everything I said about the financials, or you can just go online. Psycho is a publicly traded company on the Frankfurt Exchange. You can look at their financials and see that everything I'm telling you, look at their EBITDA margin, and you can see that they have EBITDA margins in excess of 20%, which for a wood products manufacturer is insane. And that's given their wood costs and their energy costs. Cavatex is owned by one of the biggest insulation manufacturers in the world, Suprema. And there's one that's not shown here, which is owned by Saint-Gobain, which is the biggest building product company in the world. So there are a lot of big players that are starting to think about this product and getting involved in Europe. There are 4 new plants in Europe being constructed right now. So there are 14, there'll be 18, and there'll be a capacity of $1.3 billion into the market in Europe by the end of 2023. This is a little bit about the process. It's really quite simple. What you see here, it's not that, I don't know if you guys can see it very well, but what's shown here is kind of what Jim Robbins was explaining. When they take a log and they saw it into dimensional lumber, you have a round log and you're cutting it into squares. You're always going to have some residuals left over. Those residuals, in order to make the wood products industry whole, you have to do something with it. Biomass energy is not a viable, burning it is not a viable, biomass is just not competitive with solar, wind, natural gas, all of those energy feedstocks over the long term. We have to find some value-added product to make with that fiber, and this is one of them that Jim was talking about. Paper was always that product for the industry, but as you know, since 2015, there's been 6 paper mills that have shut down. There's an excess of almost 4 million tons of softwood on the Maine market right now. It's the lowest price market in the entire country right now in the state of Maine. Once we get that chip product, we mill it, refine it with no chemicals. It's just a steam-based process. So high pressure steam just cooks it like an Instant Pot, if you know what an Instant Pot is. Basically, we have an industrial one. It's really big. We cook it with an auger feed. We push it into the refiner, which is 2 spinning plates at super high rates of speed, about 1 millimeter apart. And that makes that fiber. We add a little bit of adhesive, and then we steam press it into a board, a bat, or we just leave it as is and package it, compress it into bales and sell it as loose fill product. This is kind of what I was saying about, what is great about Maine as a place for starting this. Obviously, we're from Maine. I have 3 and 4-year-old daughters. Matt has 3 children that he raised in Maine. We believe in the Maine economy. We're passionate about it, but we're not insane. We didn't want to put up our houses, my caravan, everything I've got in order to do this, if it wasn't going to be viable for the state of Maine. Just fortuitously, Maine has a number of forces that are driving this to be what we believe to be really the best market in the country. Not the only market. There will be followers. There will be additional plants that we develop. But Maine is a great starting point because of what Matt mentioned in the video, which is we have the densest housing market in the country. This product does not transport very well. We also have the most certified acres of sustainable softwood, and this product sells. Look, it sells on its performance first, and it sells on its price. But part of the story is its sustainability and its carbon footprint. And people are going to expect this to be FSC certified, and Maine is the perfect place to do that. This is, this kind of points to this. We're not alone in the state of Maine in terms of what's happening in the forest economy. If you look at the news in the forest, in forest products across the country, Michigan, Wisconsin, Minnesota, there's all sorts of paper mills. Verso, which closed down a number of mills here, has recently closed down a number of mills in Wisconsin, Oregon, Washington, California. You see everything that's going on with the forest fires. They have no market for those residuals. They need new products. And this is, and we all need rural employment, all of these states. And this is the perfect product for that. And we can't ship. This is not the kind of product that you manufacture everything in one state and ship it across the country. It ships very poorly. It has about a 400-mile radius, which about gets us to New York City, cost competitively. At that point, once we fill up that market, once we sell out our entire mill, which would only address about 5% of the Northeast market, then we have to either build another mill here. But we also have to start thinking about how are we going to distribute, how are we going to reach other markets that are going to want this product as well. I don't know how much I could go forever, but I don't want to do that to you guys. This is a little bit about our price and about what market we're trying to address with this. That 5% is the Northeast market by the U.S. Census District. So that 5% really addresses new housing and existing housing stock market within that that area that's shown down here. And this gives you an idea of what we mean by price comparison. So price competitive. So our loose fill insulation, its price point, our whole business model is based on targeting it as cost competitive with all boreal cellulose, which is the market leader within the Northeast. It's actually price competitive per pound, but we actually, when you use it to fill a cavity, it actually requires less insulation than cellulose, but we're selling it at a price per pound competitive. We're price competitive with foam. We're below the cost of mineral wool when it comes to the board, and we're right in the sweet spot between fiberglass, which no one can catch for lots of reasons I won't get into, and mineral wool, which is the fastest growing segment of the insulation market. Again, stop me if this is all boring or you want me to go through this.
It's amazing, but I thought we ever heard one.
Well, you're hearing about it now. Well, because we haven't even started up with our manufacturing. So our build out of the facility that's going on in Madison right now. So if you drive by there, you'll see Shinbro quite active at the site. Our first product, this product, the loose fill insulation, will be available at the beginning of the second quarter of 2023. So that will be our first product that will roll off the line.
Can you go back for just a second?
Sure.
I just want to make sure I understood. I mean, you're saying fiberglass is less expensive.
Yes.
And so people want to switch just because it's good for the world?
No, I mean, there are different reasons for switching for different fiberglass. Mineral wool is the fastest growing segment of the market, but it's almost double the price of what fiberglass is. There are certain applications for which insulation is not just about thermal insulation, it's also about acoustic insulation. Fiberglass is a horrible acoustic insulator because it's very low density. Our product has the best acoustic properties of any insulation on the market. So if you think Boston multifamily, whenever you build a multifamily, you have to have acoustic insulation between the walls. So like a 2x4 stud wall that has insulation throughout, because no one wants to buy a multifamily condo where you can hear all of your neighbors. So that market is absolutely, that's a $4 billion market in acoustic insulation alone is a $4 billion market in the US. So a lot of this and the pricing that they can achieve is because they have acoustic, because of the way it's applied. It's just a very easy install and because of the acoustic properties.
Minimal, that's essentially spun rock, right?
Yeah. We can get into the carbon story about it as well, but mineral wool has a number of,
If they heat it, melt it, right?
it can only be manufactured, just to give you an idea, I grew up in Pittsburgh, and the most recent rock wool plant that was built in West Virginia, and there were huge protests about that facility being built. That gives you an idea of what the manufacturing process is about. You have to have a coal smelter in order to produce rock wool as an insulation. It has a huge energy footprint. It's one of the worst products on the market as far as carbon footprint or energy footprint.
On the phone, my understanding, phone is leading to some potential health problems. People are often install like ERP systems, obviously too tight.
Yeah, I can get into some of that performance aspects of it, but foam is what's known as a zero perm product. So that is that sort of rubber raincoat analogy. Zero perm means that it has zero vapor permeability. So if you imagine how a normal wood frame construction house is built, like all of our houses, 99% of the market in the US is wood frame construction in the residential space. If we suddenly mandate to have exterior insulation, you put the foam on the exterior, people don't think about this very much. Like we're only thinking about that in terms of reducing energy consumption, right? But when you live like a house is not a cheap beer cooler. No one wants to live in a cheap beer cooler. You want to live in a place that not just saves energy, but also has, healthy air conditioning, right? So when you're cooking, when you're showering, when you're respiring as a human being, you're generating moisture. And in the winter time in Maine, particularly, that moisture is going to migrate from high moisture conditions to low moisture conditions. So from inside to outside. And then what happens when it permeates through your wall system, and then it reaches that dew point or the cold point, it's going to stop right at that board. And so what people are seeing is that when you start to build the foam on the exterior of the building, all the condensation happens at that wood foam barrier, and that, what happens, it rots, mold, mildew, all of those kind of things. And so that's what people are concerned about. And that's why we're most excited about this product, I think, because it's totally unique in the market. It has extremely high vapor permeability. It has our value competitive with foam and mineral wool, and it has compressive strength that is analogous to foam. So when you press on it, if you press on mineral wool, it's like a sponge. When you press on foam, everyone's done that. It's hard, right? With our product, same. You can stand on it, you can jump on it. It's
biofuels market process.
It's similar. It's a much more involved refining, drying, sort of shaping process than biobricks, but a similar concept. Yeah.
So I don't know what I'm talking about at all. But when you say mineral, is that like rock salt?
Yeah,
Okay.
yeah.
So as far as rock salt compared to this product, yours is more soundproof. So why does people choose that product? Because
Yeah.
it sounds better.
Yeah.
And then also, I saw something in one of your slides that said at the bottom, something about language flame retardant or.
Yeah, so let me skip forward a little bit because that's when we, one of the best thing that happened to us when we purchased the Madison mill is in 2019, I don't know if you've ever been to the Madison mill facility, but I drove by it, people drive by it all the time going to Sugarloaf and whatnot. And I gotta admit, like, before I started doing this, I drove by, I was like, oh God, like kind of an eyesore. But when Matt and I, we ended up getting involved in this mostly because we didn't think we were going to be manufacturers. We really wanted manufacturers to do this for us because we didn't want to get involved in manufacturing. We know how difficult it is. But we went to Germany. We started working with collaborators over there. And then one day we were contacted by a large manufacturer in Germany, and they said, we have a isolated insulation plant in Germany. We're going to shut it down and have our core business to attend to. We like what you guys are doing. We want to give you first right of refusal on purchasing that mill. And that mill had one really important piece of equipment, which is the Diefenbacher board line. That's a $40 million piece of equipment. We ended up buying it for €2.5 million, the entire facility in Germany, and transporting it over here and shipping it to Searsport. Actually, disassembling and shipping it cost us $4.5 million. That's another story. So that's the line that we're actually renovating, bringing up in Madison, but we needed a place for it, right? And our investors at that point were mostly from the sawmill industry. And we thought we were going to build a greenfield facility, but what happened when we bought that facility in Germany, we realized our value, we didn't know what our value was at that point. We were just interested in the product. We realized our value is, this is going to be really hard to introduce a new product to the market. Maybe what we can do is lower the capital expense of building out a facility, which is going to be $200 million, by taking this facility in Germany and locating it in Maine. The next most expensive part besides the equipment was the facility itself. And so we started looking at Millinocket, we started looking at Lincoln, and honestly, a lot of that was just really depressing. If you've been to any of those sites, when we got to Madison and we walked inside, we were just, Matt and I were literally high-fiving. At that time, the paper machine was still in the facility, all the lights were on. There were 4 60-ton bridge cranes. They were all operational. They were taking paper rolls off and sending them to China. But the best thing that happened was once we started getting serious about that, a guy named Marty Troy, who was the head of electrical instrumentation in Madison for over 30 years, contacted me and said, hey, I heard you want doing something with my building. I was like, yeah, I guess so. He's like, all right, I'm gonna take you out to lunch. So we went out to lunch and, I pitched him and he was like, I'll help you. Best day of my life. I didn't know it at the time, but he saved us. I mean, really, we didn't know what we were getting into. I couldn't even turn the lights on without Marty. He not only sort of educated us about the building, but he brought on Joe Clark, who's the head of mechanical maintenance there for over 25 years, Rick Dino, who's the head of project management. They became our engineering team and brought 100 years of 24/7 paper manufacturing to this project. And basically, they were all retired happily. And then basically, at retirement decided, in their 50s to say, like, we're going to totally reinvent ourselves and understand this process and bring it back to this facility. That purchase, them joining, saved about $50 million of infrastructure costs. There's about $25 million of electrical distribution equipment in that building when we bought it for $1.9 million. Just to give you, like, it might sound like I'm totally BSing you, but we banked $750,000 in scrap metal from the time that we closed on that to the time we closed on the bond. And we shared that cost with Kennebec Salvage and Cowhegan. There was $1.5 million of hanging pipe and copper cable in that building at the time that we bought it. And there is more than 45 megawatts of power distribution in that facility. On top of that, which has become extremely important in this day and age with escalating energy prices, we have behind the meter power with Eagle Creek. We draw 5 cents a kilowatt hour. You might not know that, but that's like 1/4 to 1/5 what people are paying for energy right now. And we draw about 8 to 10 megawatts of energy. So that is a savings of, $5 to $10 million in operational costs. So it's been an amazing project. What Matt and I always say is it really has nothing to do with us. We were at the right place at the right time. And you can't do a job, you can't do something like this as a sole person. You need, it's way too big of a project. You need the engineering people. All of this that I didn't put together any of these slides. We have an amazing marketing and sales team. In the middle of the pandemic, our first financing deal collapsed in 2020. In March of 2020, we were actually in Germany. We had a German investor. We were in Germany when President Trump closed the travel between, at a board meeting with our final pitch there. We woke up in the morning to the travel between Europe and the US being closed. And we just basically, we left that meeting. They were like, no problem, this will pass over in no time, couple of weeks, everything will be fine. Obviously that didn't happen. In June of 2020, one of our investors reached out to us and they were like, the weakest part of your plan right now is the marketing and sales approach. There's a guy, he owned a number of lumber and building materials distribution centers, and he said, there was a guy we tried to get to replace me, and he's kind of crazy. He lives in Arica County. He's the chief operating officer for SW Collins, and he loves Maine, and he wouldn't. He considered Portland like northern Massachusetts, and he wouldn't move down there. But he might work for you. And I think he'll like your story. And that was Scott Dion, our chief marketing officer. He joined us in June 2020, left his job at SW Collins as chief operating officer at SW Collins. We told him we were going to pay him $190,000 and couldn't pay him for 6 months, basically. But he continued to work for us, built our marketing plan, and stuck with us for a year and a half, basically, while we built out an alternative financing strategy, which ended up being city bond. I just want to go and talk about some of the fire stuff because I think the videos kind of say it all. Everyone worries about bugs and fire when it comes to wood, but these products actually have higher fire ratings than fiberglass and foam. Foam is plastic, which is a petroleum product. It burns. Everyone saw the Grenfell, unfortunately, the Grenfell Towers accident that happened in London. That was based on a foam cladding that they had on the exterior of the building. This is a video of our product, the BAT product. Mineral wool tends to tout its fire resistance, so they take a little blowtorch and they apply it to their product. This is our BAT product. Scott always says, so I get a bigger torch and I apply it to our product. It has about 7% of boric acid, which is the fire retardant that's used in cellulose insulation. And that boric acid basically captures oxygen and keeps it from getting to the flame. So you apply it, it has a class A fire rating, which is the highest fire rating that you can get. So it's capable of being applied in all, even high-rise buildings. Moisture is the other thing that people worry about, especially with the board product because it's an exterior product. This is a video showing you we incorporate about 1% of paraffin, which is spindle wax, basically, into our process. And that is analogous if you've ever seen Huber has a product called Advantech that's used as a decking product. it sheets water off of it. This is basically the same process, but applied to a wood fiber insulation product. This is a picture that Matt took. This is the College of the Atlantic New Student Union. It's a 30,000 square foot engineered wood building that Matt designed, and we applied. It has 6 inches of wood fiber insulation across the entire building. What he liked about that picture is for 6 months while they were building the product, the guys who were working on the site used our product as temporary steps to get into the building. So it's just sitting on the ground the entire time. People were walking on it. It was totally fine. This is my favorite video, and then I'll kind of cut myself off of this. This is our board product. The one on the end is our board product. That has no fire retardant. And these are the competitive products. So EPS foam, XPS foam, the pink and blue board insulation that everyone knows about. And then the last product that you're going to see is our wood fiber insulation board with 1% paraffin, 4% PMDI, which is basically Gorilla Glue, and nothing else.
Yeah, how does that read artifact wise versus other installations?
Yeah, so I will I'll end with that. That's Edith. Edith did all of the is our marketing and sales manager, our marketing manager, and she did all, in addition to being our in our videos, she's also our did all of the PowerPoint presentation. So this is kind of the our product. That's a great question. Let me just skip around a little bit to show you what that looks like. If you look at the board product, it has an R value. Let me go to this size. So open cell insulations, EPS foam and mineral wool have R values of basically around 3.8 to 4 R4 per inch. Ours is a 3.4 to 3.7, depending on the density of the product. The lower the density, the higher the R value. So it's pretty close. It's within 10%. Foam is called a closed cell insulation. That has insulation values that, and they have blowing agents within them that lower their or raise their insulation value up to R5. There are some insulations that claim R7, but that declines over time in terms of performance.
Spray foam you're talking about?
Spray foam is R5. Well, if it's closed cell, if it's open cell, it's R3.8. The reason people will like spray foam is that they see it also as it fills all of the gaps and it's like a sealing agent that has positives and negatives. We talked about the sort of trapping moisture and things like that.
The 2 products that, if I understood you right, there's 2 products that you're enhancing the main product with for flame retardant and waterproofing the wax paraffin. Are those main companies that you're dealing with?
For those products. Actually, that's a good point. Most of our chemical our sort of additives are supplied by GAC and Searsport. They're our main chemical. GAC bulk imports a lot of stuff into their Searsport. If you know, they have the biggest private rail yard in the state, and they have access to that Searsport bulk shipping port. But they also manufacture, they're actually North America's biggest manufacturer of ammonium sulfate, which is another fire retardant that's used actually in Europe and in the bat and blue steel product.
And have you already established major contracts for the product and price point? Do you know where that's going to come in with, like, compared to the mineral fiber?
Yes, so the price point, all I can say in terms of like, prices have been moving around quite a bit. But we've targeted our whole business model, our whole pro forma, what we sold the bond on is based on this pricing model. So price competitive with cellulose, price competitive with foam and between mineral wool and fiberglass.
You were talking about the markets. I hear Canada. Is Canada a potential market for you guys?
It is, that Canada is really interesting. They have different building codes. Other thing that's really interesting about Canada is you think of, it's a huge geographic company or country, but and it's obviously like a big insulating climate. But all the people in Canada are living right on that like strip. The entire Canadian market is like 9% of the entire US residential market when it comes to construction. So, the reason you see so many mills on the border, like you go over from Calais to St. Stephen and there's an MDF mill there. You go across anywhere in Maine, you see a lumber mill. They're all looking down at us. And that's one of the challenging things for me because there are a lot of subsidies for Canadian manufacturers. How do we introduce value-added products that are not just going to be consumed by the Canadian market? And one thing that is really appealing about this product is the shipping advantage that you have to Maine. This product ships exceedingly poorly. So the extra 60, 100 miles that we have on any Canadian manufacturer going into the US market is a huge advantage. And I think people ask us all the time, like, why didn't some large wood product manufacturer do this already? And I think one of them is the Canadians we know for a fact that a lot of Canadian manufacturers looked at this before we did, but they all came to the same conclusion that we did, that as soon as they start up a mill in Canada and they start to prove out the market, they're just going to be consumed by some American manufacturer who's going to realize that, like, oh, I can reduce I can just be 50, 100 miles closer to the market. This is a really interesting technology because it's basically the opposite of paper manufacturing, medium density fiberboard. All the other wood products, engineered wood products, are all about densifying wood, taking a lot of wood and pressing it down into a small product. We're the exact opposite. We're taking wood and de-densifying it. And that means that at full capacity, we're only using 250,000 green tons. And that sounds like a huge amount. But when the Pixel mill blew up in Jay, they were using 2 million tons of wood. We're only using 10. Whenever we talk to people, on the West Coast about this product and expansion, they're always like, there's no wood to be sold. You can't get it into this market. And then they're like, how much do you need? 200,000 green tons. And they're like, okay, well, that's nothing. Okay, like you're fine. This product really fits in well with a lot of the other products that are out there on the market. I think another thing that's a real advantage is that it's a perfect fit for biomass energy because it's a perfect cogen CHP plant candidate because we use about 8 megawatts of electricity. If you pair that with the low value pressure, the low value steam that comes off of a biomass energy plant, like for example, Maine Pellets in Athens, they have a very efficient plant where they have a biomass plant, they're using all of their heat for drying their wood, and they're also generating electricity, which is powering their plant. So they're all self-contained. We didn't do that here because we had the hydro mill and because we have a natural gas pipeline that goes directly into the site. But at other more rural sites where you don't have those advantages, this makes for an extremely attractive, like combined heat and power plant plus manufacturing plant that utilizes all of that really, really low value wood. So if you're a logging contractor and you're bringing in logs, like the worst logs go into the biomass facility, and we can pay the highest prices for anyone with chips because we can buy the entire log and we can use every bit of that. There's like 40 more slides, but I think think we're done. So, but I'm happy to stay and answer as many questions as you like, and I really appreciate your time.
One quick one, you're just kind of thinking on the market, like, if I want to go buy for this, are you guys gonna be selling that like, hardware store, where?
Yeah, that's a great question because, we're producing about 15 metric tons of insulation an hour. That's a lot of insulation, turns out. And, selling direct to market is just, we knew right away, it's just completely unfeasible. So we've partnered with major distributors, national distributors to distribute this product. We have, we have about 3 or 4 that are sort of exclusive distributors of the product, but they will hit all of your Hancock lumber, Viking, all of that. So, yeah.
Thank you.
Awesome. Yeah, thank you, John, for your incredible presentation. I'd like to thank our sponsors for this event. This free event is presented by Dirigo Labs and is sponsored by CGI, Valley Beverage, Thomas College's Harold Alpine Institute for Business Innovation, and Briggs Co-working and Innovation Space. Drive safe, and I hope to see you in next month's speaker series.
Thank you.
Thank you.
What are you doing?